Assalamualaikum and hi, I am Nurul Ain from SBF. Here I want to present about heavy metal determination and health risk assessment of selected can sardine available in Malaysian market. I am sure that can sardine is no stranger to all of us in Malaysia. It is because can sardine is an important source of protein that contains essential vitamin, omega-3 fatty acid and low saturated fat. Whenever we go to local market for grocery shopping, can sardine product can be easily spotted on the shelf. However, even being the most common canned food products, can sardine is no exception to be contaminated by heavy metal residue which can badly threaten human health by causing health risks. The problem statement of this study is first, the demand of canned sardine is increasing due to the changing of eating trend of consumer. Second is regarding the pollution of water bodies due to numerous human activities. The study is conducted with three objectives, which is to extract the heavy metal residue from the selected canned sardine purchased from local market, to determine the concentration of heavy metal in canned sardine by using atomic absorption spectrometer AAS, and to evaluate the health risk assessment by the consumption of canned sardine in Malaysia. Next is on the literature review. Heavy metal is naturally occurring elements that have a high atomic weight and a density 5 times that of water. In fish and other marine organisms, heavy metal can accumulate in large amount in their tissue and muscles, while in human body, metals are not metabolized by the body and consequently accumulate in the soft tissue. The two classifications of heavy metals are toxic elements and essential elements. Toxic elements such as cadmium and lead do not take part in the biological system, thus cause harm to the human health even in trace quantity, while zinc and copper are the essential elements that play critical roles in biological system. According to the findings by Syafawati Ismail in Negeri Sembilan, Malaysia, PB and CD in canned sardine have exceeded the permissible limit as regulated by JECFA 1999, where zinc and copper are safely below the permissible limit. Table 2.1 shows the summary of previous studies on the concentration of heavy metal residue in canned sardine and the summary of maximum residual limit of heavy metal concentration in canned sardine as reported by WHO and FAO 2011 and FA 1985 as shown in Table 2.2. Then Table 2.3 is on the previous studies of health risk assessment on the consumption of canned sardine. Move on to Chapter 3, which is methodology. The chemical reagent and apparatus used are listed in Table 3.1 and Table 3.2. The preparation of sample required the sample to be homogenized, dried, and grounded into powder. And then for the extraction of heavy metals in canned sardine, the method applied is acid digestion method. And further determination of heavy metal concentration in the sample were done by AAS. Next, I will present about the result and discussion. For standard calibration curve, the measurement of a standard form produced linear regression with correlation coefficient R for CD is 0.9983, Cu is 0.9988, 0.9972 for PB, and 0.9992 for zinc. All of the value are above or equal to 0.995 in general or closer to 1, which depicted the detector response obtained are considered more accurate. For the metals in different canned sardine sample, it is found that the ranking accomplished is according to the average concentration of heavy metal, which zinc is the highest with 1.0464 mg per kg, followed by PB, Cu, and lastly is CD with 0.0156 mg per kg. It is also found that the level of concentration of heavy metal in all 5 samples of canned sardine of different brands did not exceed the permissible limit as stated by MFA 1985, WHO and FAO 2011 as shown in Table 4.1. The result analysis of cadmium shows that the concentration of cadmium does not surpass the permissible limit by MFA and WHO and FAO. The permissible limit of cadmium allowed in canned sardine by MFA 1985 is 1 mg per kg, while for WHO and FAO 2011, the permissible limit allowed in canned sardine is 0.05 mg per kg. Second is copper. Copper is one of necessary element as it is required for the production of specific enzyme and hemoglobin. Based on figure 4.2, the concentration of copper in 5 different brands of canned sardine are highest in canned sardine B1 with the level of 0.187 mg per kg, and the lowest concentration of copper in canned sardine B2 with 0.036 mg per kg. with the maximum level of copper regulated by MFA 1985 and WHO and FAO 2011 30 and 10 mg per kg respectively. It can be concluded that the accumulation of copper in 5 different brands of Kensadine are under the maximum permissible limit. Low level of copper help to serve as an essential element to the body, while higher level of copper will turn into toxic element within a series of time. Next is lead or Pb. Pb is one of the heavy metals that fall under the category of toxic elements where constant exposure to Pb will affect the hematological system, the central nervous system as well as renal system. As shown in figure 4.3, Kensadine B1 came up with the highest concentration of Pb, which is 0.139 mg per kg, and the concentration of Pb in Kensadine B3 was lower than Kensadine B1 by just 1 point, which is 0.138 mg per kg. Table 4.4 clarified that the concentration of Pb in all 5 brands of Kensadine were not exceeded the permissible limit by MFA 1985 and WHO and FAO 2011. The possibility of Pb contamination, particularly in canned food, is due to poor soldering work. However, in Malaysia, processed food can employ tin plate as an interior lacquer since it can withstand acid corrosion and is used as a preservative in processed food. Zinc are also heavy metals that are classified as a necessary metal alongside with copper. The level of zinc concentration in Kensadine B2 was 0.351 mg per kg, which indicates as the lowest value among the others, followed by Kensadine B1 sample, which is greatly contaminated by zinc at the level of 2.195 mg per kg. Even though the concentration of zinc were quite high as compared to the other metals determined in this study, yet the concentration value was still complied to the permissible limit which allowed by MFA 1985 and WHO and FAO 2011. By referring to the table 4.5, it is shown that the level of zinc in Kensadine conducted in this study remained within the allowable limit and do not exceed the maximum level. Other than that, the high zinc concentration studied in Kensadine could be related to the fact that the majority of zinc compounds are water-soluble and thus easily absorbed by aquatic species. For health risk assessment, the highest EDI for cadmium are calculated in both Kensadine B1 and Kensadine B3, while the lowest of EDI value for cadmium is in Kensadine B2 with 0.0005 mg per kg per day. Other than that, the EDI value for both Kensadine B1 and B3 for heavy metal lead are much more higher than EDI value for Kensadine B2 and B5. The EDI of Pb and cadmium in canned fish calculated by Kowalska in the previous research is slightly higher than the EDI which determined from this study. The data imply that the Kensadine appears to be a safer seafood product in terms of heavy metal exposure due to the packaging integrity and size of fish selected for processing. The estimated daily intake EWI of adults in Kensadine are evidently shown in figure provided. Zinc is considered as the most prevalent metal among cadmium, copper, and lead. It is proven by the EWI value of zinc in Kensadine B1, which is 0.1926 mg per kg per week, which is the highest. The comparison between EDI and EWI for adults as shown in the table 4.6 by involve all of the 5 samples of different Kensadine brand, which is B1, B2, B3, B4 and B5. The amount of EWI is greater than the amount of EDI. According to table 4.7, the THQ and HI for adults are determined in Kensadine sample where the highest average value of THQ in Kensadine are in zinc, followed by THQ in Pb. Moreover, the average value of THQ for cadmium is slightly higher than THQ for copper. Next, the determination is on the value of HI for all 5 different samples of Kensadine. The result of HI, which calculate from this study, is 0.03, which is lesser than 1.0. Thus, no cancer risk present for the Kensadine sample. It is because non-cancerous proportion is less than 1.0, while HI exceed 1.0 is predicted as cancerous proportion. From the study, it can be concluded that the concentration of heavy metal CD, Cu, Pb, and Zn were successfully determined in all 5 different brands of Kensadine purchased from selected local market in Malaysia. Thus, the ranking of heavy metal was established in decreasing order where Zn is the highest, followed by Pb, Cu, and CD. The value of EDI and EWI of adult for all the metals involved also do not surpass the PDI and PTWI as referred to FAO and WFO and also JECFA. The hazard index calculated in this study is 0.03, which is not more than 1. Thus, no possible health risk are suspected of the consumption of canned sardine. More comprehensive research on the determination of heavy metal and health risk assessment is suggested to be conducted within different types of canned fish and seafood, and also the knowledge on the health risk assessment. That's all from me. Thank you.